So in previous lecture, we talked about the normal distribution, right? And we solved it. We did like the uniform normal distribution, exponential normal distribution, I mean exponential distribution, exponential function, probability function, uniform probability function, and normal probability function, symmetrical probability functions. And we see how in a continuous random variable we draw the normal distribution. We have also looked into the direct and indirect method. Hope that you have practiced from the previous lecture. Now today what we will discuss is about the sampling distribution. So we're going to talk about two things. We're going to talk about sampling distribution and point estimation process. Basically, we are pointing towards the statistical inference. Now, what is statistical inference? Let me also go with the flow. Right, so what we're gonna today, we're gonna talk about statistical inferences. If you have remember, we already have done a little bit about this, statistical methods, which we can also call the statistical inferences. So far, what we covered, in which we discussed descriptive statistics, is in a very much detail. Right, this you have already talked about in detail, so you know almost everything about descriptive statistics. What is that? We also learned about different probability distribution as well as probability concepts. And from now on, we are going to explore the statistical inferences. This one. All right, so there are two possible. We divide the statistical methods into two possible ways: descriptive statistics and inferential statistics. We start with the discussion on a sampling distribution as well as point estimation. And we will focus on a central limit theorem today. So we will try to finish these three topics today. But if not, at least two topics we will finish. That what is sampling distribution? So this is number one topic. What is sampling distribution? Right? What is point estimation? Point estimation, as from the name point, it is showing that we are going to talk about some single value, single point, single numerical value. What is point estimation, and how we extract the things from point estimation? We will talk about this, and we will also try to cover central limit theorem. If we have time, we will finish all these three things, but at least we're going to cover sampling distribution and different aspects of sampling distribution and point estimation in today's lesson. Understand? Is it clear? Now, most of the concept you already you are supposed to be clear. You already know, right? What are those concepts? Especially regarding descriptive statistics. Now, as if you recall the initial lesson, very initial lesson, we explained statistics in two categories. That's descriptive statistics and inferential statistics. You learn different methods in descriptive statistics, like mean, median, mode, right? You all know about this thing and how to do that, how to calculate that. Now, in also including standard deviation, histogram, right? So this all, etc., etc. So descriptive statistics we use to describe the things. How we can describe the data, how we can present the data in terms of numeric, numbers, tables, right? We already have talked about this, and there are two different kinds of data we can describe in descriptive statistics. That's qualitative and quantitative, right? So quantitative on this side and the qualitative on this side, right? So number, table, and graphs. So we already talked about this phenomena. So that's about descriptive statistics. Whereas inferential statistics or statistical inferences is that based on descriptive statistics. Alright, so this one is based on this one. So first we have descriptive statistics, and based on descriptive statistics we draw some inferences. What does inferences mean? Inference means conclusion. We draw what kind of conclusion we can draw from the descriptive statistics that inferential statistics tells us about our population parameters. All right. So when we conclude about our population based on the sample data, so what is the sample data? Or you can say descriptive statistics. That's our sample data from a population. So based on our sample data, whenever we conclude about our population, uh, that is known as inferential statistics or inferential analysis. So let's start with what we already defined, inferential statistics. This inferential statistics we can subcategorize in two. Just like descriptive statistics, first you describe in qualitative and quantitative. Inferential statistics can also be divided into two subcategories. What are these? That's our estimation, and other is testing the hypothesis. What is estimation? We come to the point where we make a claim, and then in second stage we test that claim, right, which we are going to start to discuss today. So in this week and next week we will try to finish the estimation, and then next week there will be midterm, and from that onward there will be testing hypothesis. Let me go to this slide. So inferential statistics, we divide it into two main categories: estimation and hypothesis testing. Next 2 or 3 lectures, 2 or 3 lessons, I mean like weeks, will be on estimations, because there will be 2 chapters including which is being constitute of estimations, and then later on we will also study 2 to 3 chapters about testing hypothesis, and then we will finish this course unless we can also learn one more concept, that's non-parametric distribution. What are these things? This we will talk about in later classes. But next 4 or 5 chapters we will cover these 2 topics. By the end of the course you will know most of the things which can be used as a statistics student in your field of accounting. So once again, when we want to draw any conclusion based on sample data, then we define it as an inferential statistic, right? There are purpose. Why do we need to infer? Why do we need to conclude from the sample statistics, from the descriptive analysis? And on what basis we are drawing that conclusion? If you have any problem, you can just ask me question right here. Okay, but if you want me to repeat as well, if you don't understand, just ask me that I don't understand. Can you please repeat? So I will repeat. But this is really important to understand the concept because it's more theoretical. So I'm not using the whiteboard. I'm using the slide sharing. So this, so from today, we will start to learn about estimation in sampling distribution, right? So what is the purpose? As we know, when we have a population, what to do with that population, why we are interested in that population. So what's the purpose? Purpose is making decision about the population characteristics. For example, we are interested that average number of people's height in Chuanzhou or average grade of students in Huachao University, right? What is the average grade in our university or in this campus of Chuanzhou? So these are what? These are the attributes of population in which we are interested in order to what? In order to find out some conclusions. Those conclusions can be considered as inferential statistics. Now, from this population, from the students in Huachao, what I'm gonna do, I'm gonna see different attributes, right? Then based on that, I will conclude my conclusion. Now, question comes here is that whenever we want to extract any result means statistical inference, about any population, then what is the process? How do we do that? How do we make decisions from that population characteristics? Right? What is the inferential process? How do we see the characteristics? And so far, inferential process, first of all, what we need to do, right? So in an inferential process, the first thing we need to do is to gather the population and to see, to select, to pick the population in which we are interested in. For example, as I told you, we are interested in students of Huachao University or Huachao campus, then all the students in Huachao. If we are interested in the staff of some company, so all the staff of that company. If we are interested in some stock market, then all the stock prices of that all the stocks which are listed in that market. We're gonna talk about that. Now, interestingly, this population can be different for different researcher, right? Because every time we are interested in something with we want to do with something, we want to conclude differently. For example, if you are interested in companies' sale, right? Let's say we are interested in companies' sale. I'm just taking an example. Right? Then by today, means today, our company, we have sold 100,000 units. So today, we have sold 100,000 units of a product. That's what we have sold. So in this sale of 100,000 units, what is an average return of the product due to its failure, its defect? Yeah. For example, I have a company, as I told you, I sold 100,000 unit of pens, right, to the students of Huachao University. Now, some of the students, they came back to my outlet and they said, oh, this pen is not working. So they will return the pen to me. Now, they're not going to be that much pens, but there must be some proportion which are defective pens, right? So what is an average return rate of a product for this whole 100,000 unit? Now, I cannot wait for all of you to means that I cannot wait that all of you can come and say that this is working and this is not working. What will I do? I will give a 7 days or 14 days time period, and I will see that for the whole population. But for the very first day, I can conclude, I can come up with a conclusion. What kind of conclusion? For example, I sold 100,000 units, and from on this day, and in the morning, from morning session, I consider that in one first 2 hours I sold maybe 500 pen to you, and from these 500, 3 students came back. So I can conclude, I can jump to a conclusion. If 3 students from, let's say, 100 students came back in first hour, I sold 100 pen to you, to the students of Huachao, and 3 students came back that these pens are not working. So 3 pens are defective pieces. So out of 100,000, how many students will come back? 300, right? Or 3,000. 3,000 will be the rate. So that's based on this sample, I can estimate for the population, right? What is the means that's what we are talking with 10,000, 100,000 units of sale. So what is the conformance requirement? So as a student, if you have worked, then I can see another thing. Some might be interested in that population, some might be interested in another population. What is that population? That while selling 100,000 units, some of you have all of you means I have workers as well in my company. So these are my workers, right? So I can see that for 8 hours to sell these pens, how many minutes they took the break, right? And when they take the break, what is the efficiency? So depending on what kind of population we are interested in, whatever you are interested in terms of a product sales perspective, or you are interested in the break time from workers, these all are population characteristics. Right? So we start collecting the data from that, and then as we cannot check the overall population, because our population can be 100,000, so we can't collect the data from all of the students. What we do, we collect the sample data from that population. That, as I told you, that I'm gonna ask for 3 people from this population about certain characteristics, right? Or I can calculate the measurement method or draw the statistics. Yeah, so once we have collected the sample data, then we estimate that or calculate the measurement method or draw the statistics. For example, we extract the mean of a sample data, which we also say sample statistics X bar. right? So after collecting the data from the sample, now I'm gonna do some statistical work. So as an accountant, you might be working here, you might be working here, right? Um, the sample data which we also say sample statistics X bar. If you recall on this that there is a difference between statistics and statistic. This is different. This is different, right? This is a field. What is the difference between statistics and statistic? Statistic, which is also known as an estimator. What is this statistic? This is an estimator. Right? Estimator. Basically, it's a numerical value which can be calculated based on the sample data. Based on sample data, it's a numerical value, right? So this is the statistic. Now, whenever parameters are the numerical values which we measure from a population data. So first thing, population, then from that population we extract sample, and from that sample we estimate some means. And whenever parameters are numerical value which we measure from population data, so from sample data we extract X bar. Now we need to estimate this X bar, and there can be different methods to do so. Either we are interested in point estimation, so to estimate what we do, we can either estimate it and then we can test it. So we can do it through either from point estimation, or we have already learned that interval estimation. Point and interval estimation. Why is not working? Yeah, now it's clear. So there can be two kinds of estimation, point and interval. Point estimation means that whether we are estimating the population, is it based on a single numerical value or not? If it's based on a single numerical value, then it's a point estimation. For example, X bar, right? Just one value. Or it's based within the interval from this to this, a range, right? If single, then point estimation. If interval, then interval estimation. For example, if I say that 80%, I'm confident that the population value lie within this range. That it's known as it's gonna be known as a interval estimation, because the range is. Similarly, we can also run the test. For example, if a sale manager is claiming that the average return rate is 5%, so we need to test whether his claim is right or not. Test what? Test the claim. His claim can be true, his claim can be false, right? His claim can be right or not. We don't know. We have to test it. So based on sample, you get some statistics, and that statistic you estimate, and then you made a claim that whether your estimate is correct or not, whether it's representing the whole population or not. If it is, that's we do through the testing of a hypothesis. So we can do this inferential process. Based on this, we can test the claim right now. What we are talking is with the reference to the estimation. Later on, we will move towards the hypothesis testing. What is point estimation? As we have a population parameters and we need to estimate what the different types of estimators are available, right? We should know what is estimator, right? So you know what is estimator? Do you? Let me see if we have questions. No, we don't have questions. So all of you are hearing and looking at the slides very well. So what are the estimator? Estimator, oops. No, look. You should know about all the estimators, right? Estimator is the formula. We're talking about estimators. Oops. So what is estimator? Estimator is a formula which we are using to estimate the population parameter. Formula to estimate population parameter. Now, the population parameters can be mu, sigma square, sigma, standard deviation, rho, which is known as a proportion of a single population, the difference between the mean, the difference between the means of two populations, the difference between the proportion of two populations, right? We didn't talk about the rho. Rho is a proportion of a single population. So these can be different population parameters. It depends what we want to estimate. And we get the statistic against each one, right? That is x bar, s square, and small s square. They are different, right? And by that, phi hat, yeah, phi hat means like it's like this one. Phi hat x bar 1, x bar 2, phi hat 1, phi hat 2. So we can also use for x bar, for mu, estimation of a mu, population mean mu, we can also estimate mean and median and mode. So along with this x bar is mean, right? But we can also estimate, we can also use median and mode to estimate mu. Population mean mu. The question comes here is that which one is better? And we will also prove that x bar sample mean is better estimation of the population in coming minutes or in a bit of time. It's like better estimator of the population parameter mu. Similarly, for sigma square, we have capital S square and small s square, right? For this one, we can also have one small s. So capital S, capital sample variance and small sample variance. Even there is a difference, there is a slightly difference in their formulations, right? We will learn that which one is also better in this case when we are talking about the sample mean. Point over here, based on the statistics, is we are estimating our population parameter. So based on all these things, we find these things for population. So based on sample, we get the inferences, we get the conclusion for the conclusion for what? For population. So for population, we don't calculate directly because we don't have enough resources, we don't have enough time, money, and people who gonna go and ask the whole population certain questions and to get the data and then to tell us that what is the average and what is the standard deviation, how much mu1 and mu2 and different characteristics, right? So statistics is based on sample data, and population in parameter is on population data. For example, if you need to estimate mu and collected sample mean is x bar is 3. So what does that mean? What do you infer? For example, you have mu, you don't know mu, right? But you have x bar equal to 3. So this is a sample. We have taken the sample for the population, and then from that sample we get values of x1, x2, and so on, so on. But when we take the mean of x bar, it comes 3. So what inference you can get? What conclusion you can reach out? Yeah. If x bar equal to 3, what inferences can you reach out? You can simply say that this means that overall population mean is also 3, right? For example, if you take the data of a female student from this class, right, or from the Chuanzhou campus, from this campus, so what we do, we collect the data from this class, and based on that data we can predict, we can estimate the conclusion for all the campus females. Let's say total female students in this campus are 2,000, right? In Chuanzhou campus, total female students are 2,000. Just assuming that. I'm not sure how many they are. So what we do when we are interested in what? We are interested in the heights of the students. So we take the height data from this, either from, if we take the height data from all the 2,000 students, which is very hard to get, we have already learned about this, so then it's going to be population, right? But what I do, I take the height data from this class, and there are total 50 females, and I take the data from them, and average height based on this these 50 female students in my class, let's say the average height becomes 163. X bar is 163 centimeters. So every girl, some girl is like 160 centimeters, some girl is 170 centimeter, some girl is 150 centimeter, right? So I will take, like, let's say if there are three three female students in my class, so the average height will be 160. I sum up with all and I divide it. So what will be the x bar is sum of x upon n. Right, that will give me 163 centimeter. So based on this sample, what I can make and claim, I can estimate that we can say that overall in this campus, the female students have an average height of 163 centimeters. Now this may be true, this may not be true. That we're gonna test, and how to do that we will talk later in later lessons. But this is what we are doing. That's the point estimation. Remember, we already talked about point and interval estimation a bit, right? As it is giving us a single numerical value is provided by the estimator against the population, so we call it point estimation. And today we will focus more on this point estimation, and we will try to finish this point estimation, right? So if I go further, I will have random variable used to estimate a population parameter. That can be sample mean, sample proportion, sample median. I gave you an example. I gave you a couple of examples to make the concept clear to you. That's theoretical basis is sampling distribution. Now, let's take a break here. Let's take a 10 minutes break here.